Good morning, everybody. Today we're going to be working on Algebra 2, Lesson 6.2, and we are going to be solving quadratic equations by taking square roots. So this lesson supports IXL Skill K6, and remember that you are taking notes on this. You must put your header on it as is outlined here. And rather than having them uploaded to me by Saturday, I'm going to change this to this upcoming Wednesday because I got this out late for you. So this will be this next Wednesday. And what day would that be? That would be Wednesday, let's see here, the 2nd. So Wednesday, November 2. Or I'm sorry, December 2. All right? Okay, so let's move on. So we're going to be solving by taking square roots. And you're familiar, of course, with factoring, and we're just going to do a little review. So with factoring, the way we've been doing it is we've been setting up the double bubble parentheses, and this would be, let's see, x squared is x times x, and negative 25 is negative 5 times positive 5, and multiply those back up together and you would get x squared minus 25, but that's equal to 0. And since it's equal to 0, then we can take x minus 5 and make that equal to 0. And we can take x plus 5 and make that equal to 0. And then, of course, here we would add 5 to both sides and we would get x equals 5. And over here we would subtract x from both sides and we would get x equals negative 5. Now this is what x would be when y is 0. So we have two solutions. This one is 5, 0 for x and y, and this over here is negative 5, negative 5, 0, x and y. Okay, so were you to graph this, of course, you would set up a graph and you would have at x is negative 5 and at x is 5, you would have a parabola line that would go through those two places, and it's easy to find. All right, now taking square roots, it's basically the same process, but it looks and feels different. So here you've got x squared equals 49, and you don't have anything over here with the x squared. So when it's by itself, you just take the square root of both sides. So we would take the square root of x squared, and we would take the square root of 49, and so x squared, the square root of x squared is x, because basically the square and the square root are opposites of each other, and they cancel out, and then the square root of 49 is plus or minus 7, isn't it? Because 7 times 7 is 49. So here, whenever you do these, you get, and this is the chief difference, a positive and a negative number. But notice here we also, up here when we were doing the factoring, we got a positive and a negative number here. Okay? So it's the same kind of thing. And so remember that you have two solutions. Normally you would show this, this is one preferred method. Another way you could show it is x equals positive 7 or negative 7. Okay? And just whatever way the IXL skill set wants you to set it up, you do that, of course. All right, now let's look at some problems. So this one, A, we're going to solve the equation, describe the solutions, and use our calculator to check. All right, so here r squared equals negative 81. We're going to do the same thing we did before. We're going to take the square root of both sides, because r squared is all by itself. It's isolated, that's what we want. And here we have the square root of negative 81. Now that's really the square root of negative 1 times the square root of 81. Right? And so when you simplify this, of course, the r squared and the radical sign disappear for the r, and you get r equals, and then the square root of -1, of course, we know is I. And the square root of 81 is going to be plus or minus 9. So our answer is plus or minus 9, oftentimes written as 9i, positive 9i, and negative 9i. Okay, that's usually the preferred method for the way you deal with that. And so then describing the solution, these are imaginary solutions because we have imaginary numbers multiplied to the real number. So you have two imaginary solutions. All right? And so let's look at the second one. T squared equals 75. So again, we're going to take the square root of t squared and the square root of 75. And if we look at 75, it's really the square root of 25 times the square root of 3, isn't it? So we can break these up in that fashion and multiply them together. That comes up to the square root of 25. And then taking the square root of both sides, square root of t squared is t. And then we have plus or minus, and let's see. The square root of 25 is 5, and the square root of 3 just stays as it is because it doesn't have a partner to take it out of the square root jail. And so you end up with plus or minus the square root of 3, or t equals 5 square root of 3 and negative 5 square root of 3. Right? So here we have two real solutions. Okay, two real solutions. And so we can go to a calculator and we can go ahead and we could show that indeed that these are the correct solutions for what x is when y is 0. Now, to do that, we would have to change this equation. We'd have to change it to make it equal to 0. So all we would do is take t squared, subtract 75 from both sides, right? And that would equal 0. Now, we could take a calculator and we could go ahead and we can graph this. So I turn on the calculator. I'll go up here to y equals, and then instead of t, we'll use x because that's all the TI-85s really support. 84s, that is, these old ones. So x squared minus 75 is what we want. So x squared minus 75. Okay, so when we hit graph, we get the solutions here. All right, and just to check those two solutions, really all we need to do is go to trace. So you'd hit the trace button here, and then you would set your x. These are x values, right? Let's just set one to 5 square root of 3 and see what happens. So I'm going to type in for x 5, and then I want second square root of 3, and hit enter. And so you'll notice what happens. I've got a flickering button here. So that means we've got a solution that's spot on where it is on the parabola's graph. And so that's a real solution. We can find it. So this is the important thing about real solutions. You can find them with basically a measuring stick, okay? And so if we wanted to find the other side, we would use negative 5 square root of 3. So I'd go over here to negative, down here at the very bottom, hit the negative button, and then 5 again, and then second and square root of 3. And now we get the other side, and you'll see that it's blinking there. So that gives us two real solutions. All right. So all you really need to do is go ahead and use your calculator, use trace, and then put in the value. Put in the x value to check. Which is what we did. In this case, 5 square root of 3 and negative 5 square root of 3. And then we checked it. And we saw that indeed they were on the graph where it should be, right on the x-axis. Okay? Because that's where y is 0. So you want what x is when y equals 0. All right. You know, we know what it would look like if we set it up. It looks just like this. And this is 5 square root of 3, 0. This is negative 5 square root of 3, 0. Right here and right here. Okay? Let's move on. Okay, so let's look at the next one. So we will want to set this one up. So we've got x squared all by itself, right? So I want to add 7 to both sides. And when I do that, I get x squared, this cancels, equals, and let's see, 25 plus 7 is 32. All right, so then we want to take the square root of 32. Let's just use red. Square root 32 and square root of x squared. Square root of x squared cancels out, and you end up with x equals, and then 32, let's see, this is divisible by 2. 2 times, is it 2 times 16? I think so. Let's clear this. So I want 32 divided by 2, and no, that's not what I want. Clear. I want this. Okay, now I think I got it where I want. Okay, so 32 divided by 2, enter. Yeah, 16. So we've got square root of 16 times the square root of 2. So the square root of 16 is 4, right? And so you have 4 square root of 2. And remember, this is positive and negative, always positive and negative when you're dealing with it this way. And so you again have 2 real solutions. Okay. All right, now let's look at D here, and with D it looks like, okay, first thing we're going to have to do is subtract the 8. We want to get the q squared by itself, so subtract 8 from both sides, and we get 77q squared equals negative 8, right? And so then we've got to divide by 77. Oh, this is 72. This is 72. I wrote this down wrong. So let me fix that. I just realized I wrote it down incorrectly. So 72q squared equals negative 8. Now we divide by 72. So please correct this problem. It should say 72q squared plus 8 equals 0. Subtract 8, you get 72q squared equals negative 8. Now I divide by 72 on both sides. And q squared equals, well, 8 goes into 72 9 times, and 8 goes into itself once. So we have negative 1 over negative 1 over 9, right? Negative 1 over 9. Now, we're going to take the square root of both sides, right? So we're going to take the square root of q squared divided by the square root of negative 1 over 9. So when we do that, of course, the square root of q squared is q. Okay. And square root of negative 1, let's break this up into square root of negative 1 times the square root of 1. And I'll show you why, because there's a little bit of hidden stuff going on in the back. And then this is the square root of 9. So square root of negative 1 is I, right? So we want I, and then the square root of 1 is 1, because 1 times 1 equals 1. So you have 1I divided by, and then the square root of 9 is 3. Okay? And remember, this is plus or minus. So the way you would write this is q equals 1/3 I, or negative 1/3 I. And this is usually the preferred method that you would do it. Or you could do it as q equals I over 3 and negative I over 3. You could do it that way as well. But like I say, this is the preferred method. The one thing you don't want to do is you don't want to put the I in the denominator. So in other words, you don't want it to look like let me see, 1 over 3I or negative 1 over 3I. That is not what you want. The I does not go into the denominator. It's either in the numerator, because that's where it came from, or it goes to the side, like we show here. Okay? So make sure you do it in that fashion, and you will be in good shape. So what do you got here? You got two imaginary solutions. Now, with two imaginary solutions, if you try to calculate this, put it into Windows, you're going to see some interesting things happen. So let's just put that in. Let's see. So if I have, this is 1/3 I, and this is negative 1/3 I. How would I put that in? Let me see. Do I want to put it in this way, or do I want to? Yeah, I can do it this way. So I can set it up using the original equation. So if I were to draw to go up here to the y equals, let's clear this, and put in y equals 72, and we'll put x squared plus 8. So instead of q. So 72 x squared plus 8. Okay. And then we graph that. Oh, see this way up here at the top? It's telling us that the parabola is off the grid, but most important thing I want you to notice is that it's not on the x-axis. Let's see if we can get and see the parabola. So what I'm going to do is I'm going to go over here to the window button, and I'm going to change my max, which is at 10 for x, to 20. So I'm going to use 20. And then I'm going to go down here to my y max and change that also to 20. And then I'm going to go ahead and redo the graph. Now, you'll notice that there is a parabola. It's a skinny thing, and it's up here at the top. But it's right here, right off of the x-axis. Well, the thing is that graph is not touching, I'm sorry, right off the y-axis, right on each side of the y-axis. But it doesn't touch the x-axis at all. So imaginary solutions never touch the x-axis. That's why they're part of the reason why they're imaginary. But there is no solution for them when y equals 0. Just none. And that's what's happening here. If there was a solution for x when y equals 0, you would have seen it along the x-axis, and it's not there. Okay? All right, so one of the interesting mysteries of quadratics. All right, let's do the last one. And the last one here, oh God, it's got a lot of cleaning up to do. We need to get the 64 over here. We need to get the v squared stuff together. Let's first add 59 v squared to both sides. And when we do that, this leaves us with negative 2v squared minus 64. This goes away, and that equals 98. Now we're going to add 64 to both sides. Bring down the negative 2v squared. This negative 64 and positive 64 cancel. 98 and 64, what would that be? 98 plus 64 is 162. Okay, so you've got now negative 2v squared equals 162. All right. Got to get the v squared, though, by itself. Oh, yeah. Got to get the v squared by itself. So I still have to divide by negative 2. So when I do that, I'm left with v squared equals, and these are both even numbers, so 162 divided by negative 2. Oh, it's negative 81. So I get negative 81. Right? Now remember, I'm going to take the square root of both sides here. So I got a negative radical here, so there's going to be an imaginary number. So first of all, the radical sign and the exponent cancel each other out, so we have v equals, and then this is going to be plus or minus, but I've got the square root of, let's break this into the square root of negative 1 times the square root of 81. Okay? So that means v is going to be plus or minus. This square root of negative 1 is going to be I, so we'll put that here. Square root of 81 is 9. So we have plus or minus 9i. So that means our solutions are 9i and negative 9i. So again, these are, again, two imaginary solutions. And since there are two imaginary solutions, if you were to try to graph them, you'd set all this to equal to 0. You'd have to simplify and jigger this around. I'm not going to bother to do that right now, but you could do it if you wanted to. And then look for the graph of it. You would again find that the graph of this, the parabola would either be above or below the x-axis, but it would not touch the x-axis. Okay, so basically what you're doing here, your steps here, is you're collecting the like terms, so combining like terms. Then you're isolating x squared. All right. Then you take the square root of both sides. And remember, you get a plus or minus solution. Let me do it this way. You get a plus or minus solution for x and y equals 0. Okay? So your possibilities, you can have two real solutions, like we saw in the previous page, where the parabola showed two solutions, one positive and one negative, for x when y was 0. or you could have two imaginary solutions where you can't find them on the graph, or you could find one real solution. So let me just give you an example of that. Here's x squared plus 6x plus 9 equals 0. If we were to graph that, I just put this down because I happen to know that this will give us one solution. So if we are to graph that, let's go over here, clear this, and put in x squared plus 6x plus 9, and then hit graph, you're going to see you get one solution there. One solution. So that's one real solution. Again, I know it's a real solution, first of all, because there's no I in this. Now we could trace this. So we could go to trace, and we could set, well, we could set well, we don't know what x is offhand, so we would have to go through the standard trace mode. We'd have to go back up and down. But you can see it from here. It's going to be, let's see. Let's do this. I think I got to do calc first. So, calc. And then I want the 0. Okay, hit enter. Okay, left bound. Where's the, I'm not seeing the, oh, it's way up there. Let's see if I, here we go. Okay. And we'll just go to the other side, and then right bound, hit enter, right bound, enter, guess, yes. And so we get x is at -3 when y equals 0. So that's the one real solution. That's the one real solution that you've got for this. X is 3. Now you'll notice it has a 0.00. That's practically infinitesimal, and it's just a glitch in the fine-tuningness of the calculator, if you will. But it's basically x is -3 when y equals 0. So that is the solution. But even if it were x equals 3.000000001 when y equals 0, that's still a real solution. So either way you pick it, that's the way it's going to be. So the graph of it, looks like this. One solution. Okay? So you have one solution. So that's one real solution. That's one possibility for these problems that we've been doing. Or we can have two real solutions. Or we can have two imaginary solutions, which are also no real solutions. Because you can either have imaginary or you can have real, but you can't have them both. Okay? So no real solutions. These are the three choices that you have. This is what they look like. And in this one, it's either going to be up, up here, or it's going to be down here. Okay? Those vertex, obviously, but they don't touch the x-axis. Okay? All right, that's it. That's everything you need to know for this. Have a wonderful day, and we'll see you soon.